Okay. Good morning. Can you hear me? Okay. Yeah. Dear colleagues. No? 이쪽으로 할까? 가까이.
Can I do it? 여기 아까.
Is it okay? Yeah, thank you. Dear colleagues, it is my great pleasure to share with you some of our key results from the research on Asia monsoon and heat waves today. First of all, I would like to acknowledge my students and close collaborators listed here. In addition, PNU teams for Carbon Neutrality and Climate Change School and LAMP project. In our center, we have a keen interest to study the internal variability of our climate system and to respond to various forcing, anthropogenic forcing and external forcing. But out of the more than 140 ICCP publications addressing this research topic, so I have chosen a few exemplary and representative results on Asia monsoon and heat waves to highlight here today. Understanding them in more details and their response to greenhouse warming will be of great societal beneficial, because millions of people in Asia are exposed to this phenomena. The main research objective is basically to understand the underlying mechanism, determine which component is important, and understanding dynamics and characteristics, heat waves, land-atmosphere interaction. Let me begin my little scientific journey to interesting ICCP study address what atmospheric circulation should be met to generate the extreme rainfall in this Eastern Asia monsoon region. So we found this Ochuck high is closely linked to the quasi-stationary wave pattern, wave train from Ural blocking and central North Pacific blocking. So it is come from dynamic components, the change in winds. So this is mainly controlled, the change in wind, by the dynamic components, some of circulation, convergence, and advections. And then here, make to extreme rainfall Eastern Asia region, there is a very important things from the South China Sea and the cyclonic circulation here. Clear sky make more abundant water vapor resource. So this can be merged to this and to make the strong gradient of temperature and moisture here. So it is a very important source of thermodynamic factor. But we found the thermodynamic component does not solely lead to extreme rainfall, but it should be conspiring with the dynamic components. So we can say that this thermodynamically induced high water vapor components should be merged to this area. It is come from Indian Ocean and Northern Pacific region. Still, we have a very interesting in the search for the precursor or preconditioning factors to promote the monsoon rainfall. So this is another example. So we tried to understand the precursor for the monsoon onset. This is the Indian monsoon region. So we found Iranian soil moisture can be one of very important precursor for the India summer monsoon, because this area, near this area, Iranian dry soil can affect to make the gradient land-sea contrast in thermal condition. So how does it work physically? So we found initially the dry soil moisture can control the latent heat flux, sensible heat flux. More sensible heat flux make a warmer air in the upper level. This upper level warmer land, warmer condition make the strengthen this easterly wind. And then a strong land-sea contrast make the strengthen low level cross equatorial flow. So it is advanced, the onset. Almost March, April, soil moisture can advance 1.3 pentad compared to the wet, lately onset years. Okay, the wetter condition, soil moisture condition, totally reversed to the dry condition. So ICCP's researchers very interested to provide the future projection. This is one simple question. For given 1 degree warming, which monsoon area are highest sensitivity? So we divided, for this, we divided 4 Asia monsoon region: East Asia, West North Pacific, and India and Indo-China Peninsula monsoon. At the case, in terms of mean rainfall sensitivity to the 1 degree warming, we found the India monsoon has the highest 5.4% for 1 degree warming. In spite of very spread of among the models, we used the CMIP6 models. But we know theoretically, Clausius-Clapeyron relation, but there's a little smaller, but the highest value can be found in the India monsoon area. But another interesting thing is a change in maximum daily rainfall. We pursued several methodology to provide the extreme rainfall change. So this is one example, maximum daily rain. East Asia monsoon has the highest sensitivity, as almost 70%, but other monsoons are very similarly distributed. There is a very higher values compared to the global monsoon. But still here, it's not worth noting, there is a high uncertainty. So we need to reduce this uncertainty because we need to allow policymakers to make the relevant decision for the regional scale. So this is another example. The question was when the anthropogenic signal in monsoon rainfall will become visible or detectable. So we found some area difference here. We used conservatively time of emergence. This time of emergence, TOE, is the time when the anthropogenic climate change signal become larger than the inherent variability of the climate system. So we provided the anthropogenic signal by estimating from the ensemble mean. We used the large ensemble CSM model. So internal variability is estimated by the intra-ensemble spread as a noise. So this is a result for the mean values. Time of emergence, here very distributed, very wide range of TOE across the monsoon regions. Here, the wetter region, the drier region, the differently shown. And also, the early emergent area is Africa region, India region, but the late emergence region is located at the Eastern Asia region. But it is very strong evidence to tell us there is a very importantly time of emergence of extreme events. Extreme events has a very similar TOE, almost 2040, 2060. This is strong evidence to tell us our tail of probability distribution of rainfall is more sensitive than the mean. So I will show the watch the little movie. I will show the little movie showing the wind in blue, orange, the rain in red, the cloud in white. So this is from the RBCM3 model, 9-kilometer model with the OpenIFS atmosphere model and the PESOM2 ocean model. So focusing this India monsoon here we focus this India monsoon. We can see the topographic feature here, such as the Western Ghats, play a key role in anchoring the summer rainfall. And mesoscale system with the small-scale filament can also contribute to the extreme rainfall here. But you know these features are not well resolved in CMIM model, low resolution model. So we need to go to the high resolution model. So this awareness motivated us to have two recent studies using the CSM 1.2 high resolution model result. So one study, we re-examined the Asian monsoon response for various types of CO2 fluctuation. We discussed the thermodynamic factor and withdrawal days. Another papers, we focused greenhouse warming effects on the orographic rainfall. Here, orographic region very strongly boosted the rainfall here at the condition of greenhouse warming. So we identified a new orographic moisture omega feedback mechanism, which help boost the orographic rainfall in warmer climate. But we are here we can see the drier area also. So this orographic moisture feedback mechanism shows the loop chain. Suppose this change in relative humidity in low level, and this one promote vertical motion, and then eventually rainfall cloud condition were done. So its reverse is can be called here drier region. So this is important to use the high resolution climate model properly capture topographic feature and roughness. Let me move to the heat wave. So by switching gear, looking at this heat wave condition, this is we found there are different flavor, dry and moisture heat waves. As a confound perspective, we use the temperature condition as well as but we use the employment of relative humidity. So dry heat waves characterized by the high temperature and the high relative low relative humidity less than 33%. And moisture heat waves characterized by the high temperature and high relative humidity more than 66. So we divided dividing this dry and moisture. You can see the different areas here. Distinguished areas are located at northern part of China and southeastern Asia. So there is controlled by the different feedback process, and also plants are very sensitive here. So their feedback process showed differently. Surface dynamic and the latent heat flux feedback is very important here, but moisture heat waves has feedback attribution of cloud and water vapor, differently controlled by different feedback process. And then we get the future projection. For the dry heat wave is a little extended and enhanced, but moisture heat wave is more extended, more bigger area. And then looking at the timing of time series of this one is a time, and this is the annual calendar days. So we can see there, until this end of 21st century, this dry heat wave is very enhanced and longer time of heat wave time. But interestingly, the moisture heat wave showed the springtime, this heat wave occurs. This advancement of onset is very important to the agricultural part. And also, as a two peaks, this moisture heat wave duration is very longer, almost from March to October. So it is can influence to the agriculture and human and mammals condition. So to better understand this how this heat wave condition, we thought this surface dynamic is important. So we can get the information from the land process. So after that, we studied the confound soil moisture and heat waves. Here, interacting atmosphere land process, we considered the important factors. Soil moisture can control the latent heat flux, sensible heat flux, and then eventually weather condition is emerged to make temperature. So we employed soil moisture temperature coupling strengths to show the land process for the confound drought and heat waves. So this coupling strength is measured by the sensible heat flux, actual minus potential values. It's a response to the radiational heating and cooling, and then with the latent heat flux, the sensible heat flux, is importantly regulate each other. So this is measured also as soil moisture deficit here. So soil moisture included the land process is very important. So this is land atmosphere interaction based confound drought and heat waves. Confound drought heat waves increased here. This is a linear trend in the spatial distribution showed this area is very highly increased. So this area, we have a time series normalized the coupling strength and sensible heat flux actual minus potential and T prime. Strikingly here, some time before time, after this time, we called change point. We detected a change point, and then we showed a regime shift in these points. After these points, strongly coupled CS, coupling strength, and sensible heat flux actual minus potential and T prime is synchronized very much. So it will be changed with the condition of global warming. So this area has the agricultural area. There's many agriculture area that should be severe affected by the severe confound drought heat wave condition. But still, we have the future drying trends and including the land surface processes. But this more refined perspective still leaves out another important contributor. What is that? That is plants, I think. So to understand the role of the plants through the heat wave dynamics, we want to include the role of evapotranspiration with the plants and stomatal conductant, root access to soil water, potential source of aerosol through fires. We are exploring presently with my student collaborators. I think that is biosphere nexus between the atmosphere plants and soil processes interaction. Let me conclude my talk by saying our understanding on Asian monsoon and heat wave and their interaction has really broadened our understanding for the future at the interface of land atmosphere. So after my Q&A, my colleague Christian Franske will show another example of the lake, reservoir, and permafrost while region. Thank you very much for your interest.